Hello, welcome back. Today we are going to talk about consumer choice and utility maximization. In the lecture today, we are going to talk about the following issues. First, we are going to define what utility is and what consumer decision making process actually looks like in economics. And we are going to lay out the basic assumptions that we usually follow when we think about consumer decision making process. Basically, consumer decision making process is about trying to understand how consumers make their purchasing decisions. And we are going to provide some kind of economic theory to understand and characterize how those decisions are taken. We will then talk about how this decision-making process results in a demand curve. Our demand curve, as you have learned before, shows us the combination of price and the quantity that a consumer is willing to buy at those prices. Now, a demand curve gives us an idea about what the consumer is willing to buy. Now, this willingness really comes from a deeper behavior of the consumer. So we need to understand the behavior of the consumer so that we can understand what the consumer is thinking when he is making those purchasing decisions, and whether those decisions lead to a downward sloping demand curve, meaning that there appears to be a negative relationship between price and the amount that our consumer is buying. So we'll highlight those issues. A major issue that we are going to focus on in the first part of this lecture today is this idea of rationality. Our consumer, by assumption, will be rational, meaning that they do not really make any haphazard decisions. Their decision-making process is not random. They follow some specific methodology, some kind of thought process goes into their decision to buy something. Now, obviously, we can ask the question of whether our consumer is rational or not, meaning that whether our consumers always make a systematic decision to purchase things. We will show some example, some theoretical example about some choices that appears to be irrational, and we are going to show that those kind of irrational decision-making process could lead to a demand curve which looks very different from the ones that we looked at before. To be more specific, if decisions are irrational, our demand curve could be upward sloping. After covering this, we are going to develop two very important graphical tools. One is called an indifference curve, and the other one is called a budget constraint. We are going to show that these two graphical instruments or tools can be used together to give you a graphical illustration as how our consumer makes those really complicated rational decisions. At the heart of those decisions are this idea that our consumer is always trying to get the maximum possible satisfaction from his or her purchasing decisions, but those decisions are constrained by how much income they have. So our graphical illustration will indicate this constraint optimization by our consumers. Part of the constraint is that they have a limitation of income. We are going to talk about budget constraint, which will be a way to represent the choices that our consumers can really afford given the prices of the goods. Then we are going to define something called indifference curve, IC, that basically represents consumers' preference towards goods and services. Okay, with these two ideas taken together, the budget constraint and the indifference curve, we are then going to show how our consumers divides his or her resources between two goods, because we are going to look at simple examples. We are going to show that with the help of these two graphical tools, we can show utility maximization or decisions that really reflect the optimal consumer decision making process. Now, obviously, this utility maximization, or the bundle that helps the consumer to derive the optimal consumption, optimal utility, is not a fixed one, because as we are going to see that if any time there are changes in the environment of our consumer, meaning that there are changes in the income, the price, or some other deep behavioral issues, those optimal consumption bundle will change. We are going to talk about those changes in through the lens of another two very important concepts in economics. They are called income effect and substitution effect. So we have a long list of things to look at in this particular discussion, so let's move on. The first thing that we're going to start is by talking about utility and consumer decision making process. From the onset, we are going to be very careful about what kind of decision making process we are talking about. From the onset, we are going to be talking about rational consumer decision making process. So what does this rationality means? The rational decision making process is a very simple idea. It means that we are only going to focus on decision making process where the consumer tries to find the best bundle that gives that gives him the highest possible satisfaction given the income that he has. So when we look at this rational decision making process, all of these decisions are designed to make our consumer as well off as possible given the scarce resources that our consumer has, which is their income. So this rational decision making process therefore has two elements to it. One is this idea of satisfaction, and the other one is the idea of income limitation or resource constraint or scarcity, something that we know that are very important to us. The satisfaction part of this decision making will be explained through this concept of utility, and the income limitation part of this decision making process will be explained through a discussion of budget constraint. Okay, so before we look at each of them separately, let's get sort of like a very precise idea about what we are about to look at. So all the rational decision making process that we are going to look at will involve finding the consumption bundle that gives our consumer the highest level of utility given their budget constraint. So that's what we want to do. So let's start with, so we are now in the process of trying to understand utility maximization. So what is utility maximization? Now, utility maximization is a combination of different ideas. So let us slowly develop a set of ideas and then we explain what utility maximization is. Our first topic of discussion is this idea of utility. What is utility? In a very simple term, utility is a measurement of happiness or satisfaction. Economists regularly refer to enjoyment or satisfaction that people obtain from consuming goods and services as utility. There is a lot of debate about what utility is and what utility represents. Some people think that utility is a unit of measurement for satisfaction. So just like you use liter to measure milk, you can use some kind of unit of measurement to measure your level of satisfaction. This is called a cardinal measurement of utility, where utility can be measured by this concept called utils. Then there are other people who argue that satisfaction really cannot be measured. Satisfaction can be basically compared between individuals by saying that someone is happier than me or I am happier than someone else. So a lot of economists argue that utility is basically can be compared, they can be ranked in more formal terms. People argue, these economists argue, that utility is basically an ordinal concept, meaning that you can only compare utility rather than measure utility itself. When we talk about utility, we obviously have to talk about something called marginal utility. So this is the amount by which utility would change when your consumption bundle changes by 1 unit. So you buy 1 more unit or you buy 1 less unit, by the amount by which your utility changes are going to be called marginal utility. Now our marginal utility basically gives an idea about how what extra utility you get by buying 1 extra unit of output. As it turns out, this marginal utility is subject to a law of diminishing returns. There is a rule for that. It's very important. It's called the law of diminishing returns, which is basically very similar to something that we are going to see in a couple of chapters later called law of diminishing returns. The law of diminishing marginal utility says that whenever the consumer buys more of some good, they get less and less extra satisfaction, and it makes perfect sense. The example that I always like is the example of oranges. So imagine that you are buying oranges for the first time in a given season. You are very excited about the orange. When you buy the first orange, the extra utility that you are going to get is very large because this is the first orange of the season. You are very excited. You are very happy, right? Now imagine continuing to buy more and more oranges, and when you are buying the 10th orange, you are probably exhausted, right? Your stomach is probably already upset after consuming 9 oranges. So the 10th orange is probably going to give you much less utility than the first orange was giving you. So you can see immediately that the idea that as you buy more of something, the extra utility sort of goes down makes perfect sense. So law of diminishing marginal utility is very important, and I think it is very intuitive. Let's now spend a little bit of time looking at some graphical illustration of these ideas, right? What you're looking at is an artificial table where you are looking at some units of some basic output. In this case, it's pizza that you are buying. You are buying from 0 to 1 to 5 to 6. As you can see, every time you buy something, you get extra utility, and the total utility that you get by buying extra unit of output is going up. So it makes perfect sense, right? Because we are rational. I know if I am buying something, that thing has to give me some kind of positive utility. If my utility is negative, that means I am not rational. Now what we are going to do now is we are going to create another column where we are going to measure the marginal utility associated with each of these units that we have just purchased. For example, when we are buying the first unit of pizza, our marginal utility is 20, right? It's the difference between these two. When we are buying the second unit, our marginal utility is 36 minus 20, which is 16. When we are buying the third unit, the marginal utility is the difference between 36 and 46, so it's 10. The next one is like 6. The next one is about like 2, and the last one is kind of like negative, right? So you can see that these are all marginal utilities, and you can see clearly that the marginal utilities are really going down from 20 to 16 to 10, 6, 2, and then negative, right? So what we do is we measure total utility in a 2-dimensional space like this, where as you buy more, your total utility is going up. That makes perfect sense. But as you buy more, your marginal utility sort of goes down. So both of them are consistent with what we understand about total utility and marginal utility. So let us now move to the move to something that is going to be at the heart of our discussion today, which is called utility maximization. So in a very simple words, utility maximization refers to a consumer trying to buy a bundle of goods and services that maximizes the utility of the consumer with the budget constraint in keeping in mind. So given your income constraint or income limitation, the consumption bundle that gives you the maximum utility is the bundle that maximizes your utility. Now, there is a rule that you can follow to really find out that utility maximizing consumption bundle. So imagine that you have two goods that you want to buy, good X and good Y, and let's say the price of those two goods are PX and PY, and our utility maximization rule says that you are going to buy quantities of X and Y up to the point where the marginal utility per dollar on these both goods are equal, which means that you buy a certain quantity of X, and that certain quantity of X gives you certain amount of marginal utility. And after you get that marginal utility, you take the price with it. And then you take the price with it and divide that by the price. You take the marginal utility of that good and you divide it by the price. You get what we call marginal utility per dollar on good X. You do the same thing for good Y, and then you equate those two. As long as these two ratios are not equal, your utility is not maximum. Now let us go very slowly and try to understand this utility maximization rule by looking at several examples. The first example is a very interesting example. Imagine that, so what we're looking at in the table is a situation where you are trying to buy two goods. You are trying to buy a combination of slices of pizza and Coke that gives you the highest amount of utility. So the price of pizza is $2, the price of Coke is $1. So what you see in column number 1 are the units of pizzas that you can buy. The column 2 shows the associated marginal utility. Column 3 shows the associated marginal utility per dollar, where you take column 2 and it divided by the price of pizza, which is $2. So 10 when you are buying this first unit, your marginal utility per dollar, marginal utility was 20. So the marginal utility per dollar is 20 divided by 10, which is 20 divided by 2, which is 10. You do the same thing for the Coke, and you find column 2, which is the corresponding marginal utility per dollar from Coke. Let me clean up the table a little bit, and I am going to now look at whether we can find combinations of Coke and Pepsi where the marginal utility per dollar are equal. If you glance on this very important table, you are basically comparing between column 3 and column 6. You will see that there are 3 particular levels where the marginal utility per dollar are equal. For example, there is a level where marginal utility per dollar on the first unit of pizza is 10, and the marginal utility per dollar on the third unit of Coke is 10. So this seems like it satisfies one of our conditions. But then we see there are some other conditions, other situations as well, where, for example, when you are buying the third unit of pizza, the marginal utility per dollar is 5. When you are buying the fourth unit of Coke, your marginal utility per dollar is also 5. So that's another example where you can basically maximize your utility. There is a third one that also makes a lot of sense, right? And that one is, you probably don't see that because I have probably eliminated that. The third one is basically 3, right? 3, right, where you can buy 4 units of pizza, marginal utility per dollar is going to be 3. You can buy 5 cups of Coke, and marginal utility per dollar is going to be 3. So you now see 3 different combination of goods and services where our marginal utility per dollar condition is satisfied. So the question is, which combination are we going to choose? Okay, so the answer lies in our discussion about income, right? So when we analyze these three consumption bundles, and they are there for your analysis. So let's just look at some of them. So imagine that you are trying to, so if you think about the first consumption combination, which was 1 slice of pizza and 3 cups of Coke, their marginal utility per dollar was 10 on both case. When you take a look at the total spending, which is 2 times, so you find out how much you spend is you figure out the total amount of spending on slices of pizza, which is 2 times 1 slice of pizza, plus total spending on Coke, which is 3 cups times 1, $3. So the total expenditure is $5. And if you look at, if you go back to the previous table, which you can do later on, you can see the total utility by buying this 2 is going to be 65. You can similarly, calculate the cost of buying 3 slices of pizza and 4 cups of Coke, where the marginal utility per dollar is 5. You will see that the total expenditure is 10. You can also calculate the total cost of or spending on buying 4 slices of pizza and 5 cups of Coke, where the marginal utility per dollar was 3. Marginal utility per dollar was $3, and the total expenditure is 13. We now want to spend a bit of time looking at these 3 numbers. If you look at these numbers, the story goes like this. If you can spend $5, you can afford the first bundle, and that obviously maximizes your utility. If you can afford $10, the second bundle can give you the maximum amount of utility, which obviously, as you can see, is higher than the previous one. And if you can afford the third bundle, if you can afford $13, you can buy the 4 slices of pizza and 5 cups of Coke bundle, and that gives you even a higher level of utility. So now, before we move on, we need to understand these 3 numbers very, very carefully. When we talk about utility maximization, we are talking about the maximum utility that you can get given your income constraint, right? So we want to now interpret these numbers. If your income is $5, the maximum utility that you can get is 65 by buying 1 slice of pizza and 3 cups of Coke, and that will be your maximum utility. If you can afford $10, the consumption bundle that maximizes your utility is 3 slices of pizza and 4 cups of Coke, and the total utility that you get is 96. If you can afford $13, the consumption bundle that maximizes your utility is 4 slices of pizza and 5 cups of Coke, and the total utility that you get is 105. Let's look at a second example. This example is very similar to the previous one. Let's just glance over the table. So the first column that we're looking at is the number of cups of soup that you buy, the total utility, marginal utility per dollar on soup. Then you have marginal utility per dollar on sandwiches. So basically, when we are carrying out our analysis, we are basically look at these 2 columns, column number 4 and column number 1, 2, 3, 4, 5, 6, 7, 8, column number 8. Okay. Again, you can see that there are several levels of several level where the marginal utility per dollar is equal. First of all, when you buy 2 cups of soup and then 2 sandwiches, your marginal utility per dollar is $10. When you are buying 3 cups of soup, your marginal utility per dollar is $6, and when you are buying 4 units of sandwiches, your marginal utility per dollar is 6. So that's also another sort of like utility maximizing situation. Let's just combine them. And then there is a third one, right? When you buy 4 units of 4 quantity of soup and 5 quantity of sandwiches, that can also have lead you to maximize your utility. So you have 3 different combination of goods and services that can maximize your utility. So the question is, which one are you gonna choose, right? The one that you're gonna choose will be based on your income. So in this particular question, the question says that your income is $18. So if $18 is how much income you have, let's just calculate the cost of the first bundle, which is the cost of 2 soups and 2 sandwiches. And if you do the calculation as it is shown, your total expenditure is $10. The cost of the second bundle, 3 units of soup and 4 units of sandwiches, the cost is 18. And the cost of the third bundle, 5 units of soup and 4 units of soup and 5 units of sandwich, the cost is 23. You should see clearly that since your income is 18, you really cannot afford the third bundle, and you really do not want to buy the first one, because the first one, although it maximizes your utility, but you can get a higher level of utility by buying a better bundle that leaves utilizes all your income. None of your income is unutilized, and that's the bundle that you want. So the choice is going to be B, for 3 cups of soup and 4 units of sandwiches. So that's one kind of idea. Let us look at another example, right? Let's read the question that is in the slides. If Valerie purchases ankle socks at $5 and gets 25 units of marginal utility from the last unit, and bananas at $3 and gets 12 units of marginal utility from the last bananas, what is she doing? So let's try to look at that. So for this person, the marginal utility per dollar from socks is basically 25 divided by 5, which is 5. The marginal utility per dollar on bananas is 12 divided by 3, it is $4. Now let's look at that situation. It should be clear that the marginal utility per dollar on socks divided by price of socks is basically greater than marginal utility on bananas divided by the price of bananas. Do we all see that? Okay. So this is a situation where the equality is not achieved, so you are really not maximizing your utility. So what can you do? As it turns out that there are several things that you can do. First one, you can buy more socks. Why? Because if you buy more socks, your marginal utility per dollar is gonna go down. On socks go down, then this entire ratio is gonna go down until you find equilibrium. So that's one thing that you can do. The second thing that you can do is that you can buy less banana. So if you buy less banana, if you remember the law of diminishing marginal utility, which says that if you buy more, your marginal utility goes down, but if you buy less, your marginal utility goes up. So if you buy less banana, your marginal utility per on the banana is gonna go up. So this entire ratio will go up until this sort of becomes an equilibrium. So there are 2 things that you can do. So so the answer could be any of these 2. If you the given answer, if you look at the answers, you can see that our option number 1, where we can buy more socks, is not available, but our option number 2 is basically available. It says you want to consume more ankle socks and fewer bananas, and it makes perfect sense, right? So this is one way to look at utility maximization, by looking at the marginal utility per dollar condition. Okay, so what we're going to do now is we are going to try to understand how these utility maximizing consumption bundle that we have just talked about can lead to the derivation of the demand curve that we have looked at in previous chapters. So our discussion will focus on trying to understand how utility maximization is related to the price. Okay. Now remember that our law of demand says that our demand curve is downward sloping, meaning that as the price goes down, you buy more of that good, right? So as the price goes down, why do you buy more of that good? Okay. So if we believe that our utility maximization is consistent with a law of demand, we have to show that whenever price goes down, a consumer buys more of that good and still maximizes his or her utility. So how can we show that? We can show that by the use of two very important concepts. The first one is called the substitution effect. The substitution effect is a concept. It is talking about it talks about how the consumer responds to a change in price. The substitution effect of a price change refers to the change in the quantity demanded of a good that results from a change in price, making the good more or less expensive relative to the other goods, holding constant the effect of the price change on consumer purchasing power. So the idea is like this. Our substitution effect tells you that whenever price changes, if you keep the purchasing power unchanged, because by the way, whenever price changes, your purchasing power will change. We're going to talk about that in a minute. But if you can keep that constant, then there is a certain way our consumer should respond to these price changes. The response to price changes according to substitution effect is always negative. What does that mean? It means that whenever the price of a good falls, substitution effects tells you that you should buy more of that good. Why? Because our substitution effect tells you that whenever one good is cheaper than other good, you should always buy the more cheaper good and buy less of the more expensive good. So the idea behind substitution effect is that as a consumer, whenever the price of a certain good goes down, we substitute the more expensive good with the relatively cheaper good. So that's where the substitution effect is. So the substitution effect is always negative. What does it mean? It means that if the price of a good goes down, this good becomes cheaper, right? Relative to the other goods that the consumer is buying. So the substitution effect tells you that if the price of a good goes down, you should buy more of that good. The opposite is also true. Substitution effect tells you that if the price of a good goes up, you should buy less of that good, holding everything constant. Okay, so the opposite is also true. So that's our substitution effect. The next one is what we call an income effect. So income effect is very interesting. The income effect of a price change refers to the change in quantity demanded of a good that results from the effect of the change in price on consumers' purchasing power, holding everything else constant. So what does it mean? Whenever a price of a good changes, we argue that it changes the purchasing power of the consumer. Why? Because you can think about it, right? You are thinking about buying a couple of goods, and whenever one of the price becomes cheaper, you now can think about buying a different combination. Your purchasing power suddenly just went up. You can buy more of the cheaper good. You can also spend a little bit of time, more money on the more expensive good. You can do a lot of different things. So when price of a good goes down, it increases the purchasing power. It means that it increases how much you can buy from the market. The opposite is also true. If the price of a good goes up, the purchasing power of the consumer goes down, meaning that he now can afford to buy less of everything. Now, the income effect is interesting in a sense that income effect can be both positive and negative. Okay, so for a normal good, the income effect is negative. So what is a normal good? A normal good is a good for which, as your income increases, you buy more of that good. Very simple idea. So what do we mean by a normal good? So it's almost every good that we see around us. These are goods that we like, and we need them. And whenever the price of those goods go down, whenever the income of the consumer goes down, we buy less of that good, and whenever the income goes up, we feel richer. We feel like, hey, I can now buy more, and we buy more. So this is what we call a normal good. Most of the goods that we buy from the marketplace are normal goods. For a normal good, income effect is negative. What does it mean? It means that whenever the price of a good goes down, remember, it increases the purchasing power of the consumer, meaning that this is like, although you are getting the same paycheck, but since everything is now cheaper, or at least one of them is cheaper, you now can afford to buy more. And in that more situation, our income effect tells you that you should buy more of the good whose price have just gone down. Okay. So that's a normal good, where as your income just went up, you are also buying more of that good. But then there are a second category of goods, and they're very interesting. The second category of goods are what we call an inferior good. An inferior good is a theoretical concept, although in recent times there has been some empirical evidence. An inferior good is a good for which if the price of the good goes down, you buy less of that good. And if the price of that good goes up, you buy more of that good. And for a very long time, people really had trouble understanding that, right? Why would I buy less of a good if the price of that good goes down? I mean, I should buy more, right? Now, on a theoretical side, inferior goods are goods that can have some kind of brand loyalty. So let's say you are poor and you go to Walmart and you buy Walmart jeans, branded jeans. You don't really care about other more expensive brands because you cannot afford that, right? When your income increases, you feel like, hey, I can now afford to buy a Lee or a Levi's, a more branded jeans. So what happens is that whenever your income increases, you stop buying the Walmart brand and you buy more expensive brands. Do you see the connection? So your income went up and you started buying less of the Walmart brand. So the Walmart brand good is an inferior good. This particular phenomena was first observed during the Black Death situation in Europe, where so many people died. Many of them were farmers, that Europe had a serious food crisis and people started eating a lot of potatoes. And over time, when people's income started increasing, their consumption of potatoes started going down, which was counterintuitive, but then economists argue that potato is an inferior good. When your income increases, you buy less potato and you buy more expensive carbohydrate source like pasta. Okay, now in case of an inferior good, your income effect is positive, meaning that if your income goes down, you buy less of that good. You buy less of that good. I apologize. Your income for an inferior good, the income effect is positive, which means that if your price of a good goes down, meaning that your income is going up, you buy less of that good. And if your price goes up, meaning that your income is going down, you buy more of that good. So notice that in this case, income effect is positive because the movement of how much you buy is in the same direction with the price change. When price goes up, you buy more. When price goes down, you buy less. So that's like the positive relationship that I'm talking about. Now, in the slide, in the discussion, I have added a slide where the discussion that I just had is summarized. So please read that on your own. I am going to now define law of demand for these two very different kinds of goods that I have just talked about, the normal good and the inferior good. For the normal good, the law of demand is very straightforward. Why? Because whenever the price of a normal good falls, our substitution effect tells the consumer to buy more of that good, straightforward. Our income effect also tells our consumer to buy more of that good. Notice, in case of a normal good, both income effect and substitution effect are negative. So price goes down, you buy more according to both income effect and substitution effect. As a result, whenever the price of a good falls, consumers buy more of that good, resulting in our traditional law of demand, which means that our demand curve for a normal good is downward sloping. Okay, now in case of an inferior good, things are very interesting. Why? Because substitution effect, as I told you, is always negative. So when the price of a inferior good, I apologize, there is a typo. Let's just change that. When the price of an inferior good falls, substitution effect tells the consumer to buy more of that good, because that's what substitution effect always does. Then income effect tells our consumers to buy less of that good. This is where the interesting discussion is coming, right? So now we are seeing substitution effect and income effect moving in opposite direction. Your substitution effect is telling you to buy more, your income effect is telling you to buy less of that good. So obviously you can have two different kind of situations. The first situation could be where the demand curve for the inferior good is downward sloping. Why? Because this could be a situation where the negative effect from the substitution effect really dominates the positive effect from income effect. So the net effect is a negative effect. So negative dominates positive. So you still have negative effect from this price cut. So price goes down, the effect is negative, meaning that you buy more, so you have a downward sloping demand curve even when the good is inferior. But then you can have a final category of goods, which is what we call a Giffen good or a Giffen good syndrome. In case of a Giffen good, you can have a situation where the substitution effect, the negative substitution effect, is weaker than the positive income effect. So the positive income effect of a price cut dominates the negative substitution effect. So the net effect is a positive effect. So price goes down, that overall effect is positive. So meaning that when the price goes down, our consumers' income increases and our consumer buys less of that good, right? So price is cut, our consumer's income increases, and our consumer buys less of that good. So here we are seeing a positive relationship between price and quantity demanded. We know that when price and quantity demanded move in the same direction, meaning that when price goes down, your quantity demanded goes down. It is also true that in this case, when price goes up, your quantity demanded is going to go up. You will finally get a upward sloping demand curve. An upward sloping demand curve. This is very, very unusual and very interesting. So in case of a Giffen good, the demand curve is going to be upward sloping. Is this true? Does this make sense? As it turned out that in very recent times, there has been some kind of empirical evidence, and the evidence is from China, where it was observed that when the price of rice was going down, people were buying less rice. So the one way to rationalize this is going back to the Black Death example, where when the price of rice was going down, people thought, hey, I mean, I should not buy this cheap rice because I can now buy something else. Let's buy more expensive carbohydrate source and buy less of rice. So obviously rice in a country where rice is a very large component of your nutrition, like China, you can actually have a Giffen good syndrome, meaning that the demand curve could be upward sloping. Okay, so let us now move to the second part of this chapter, which is now. So we have now looked at utility maximization. We have defined the utility maximizing rule, which is equalizing marginal utility per dollar across different goods, and we have shown how the utility maximization can be connected with our demand curve. What we're going to do now is we're going to offer you a second way of looking at utility maximization, but now we need two new graphical tools. They are very interesting, and we are going to call them budget constraint and indifference curve, and we're going to use these two to really explain utility maximization from the perspective from a graphical perspective. So let's move on. The first concept that we're going to talk about today is called the indifference curve. So the indifference curve is a curve. It's a graphical tool, as I mentioned, that shows combinations of consumption bundles that give the consumer same utility. So this is a downward sloping line in a two-dimensional space that gives you combinations of different goods for which the consumer gets the same utility. Our indifference curves have say 5 properties. The first property is that our indifference curves are downward sloping. So let's look at that. So this is a two-dimensional diagram where you have mangoes on the vertical axis, an arbitrary good, and you have fish on the horizontal axis, another arbitrary good. When indifference curve is downward sloping, it means that if you give up some mango, let's say you give up buying some mango, in order to be on the same utility level you have to buy some more fish. So there is a trade-off between fish and mango that can give you or keep you at the same utility level. Okay, so you buy less you buy less mango, you have to buy more fishes to be on the same utility level, right? This is assuming that the prices don't change. So if you suddenly decide to buy less of one good, you have to buy more of the other good, right? So this is kind of makes sense, right? If you buy less of something, part of your, you might get a loss of utility, and that utility has to be compensated by buying more of the other good. So that's why the indifference curve is downward sloping. Okay. Higher indifference curve indicates higher utility. We want to spend a little bit of time looking at this particular example. The example basically starts with the table that you are looking at. The table is an artificial table that shows you A, B, C, D, E, and F, basically 6 different bundles of goods that gives our consumer probably different levels of utility. We really don't know, right? Each of these bundles have different combinations of goods and services. I want to start with plotting each of them. So let's start with A. A has 1 unit of pizza and 2 units of Coke. You can see clearly that B, then F, then E, all of them are probably better than our bundle B, right? B has 3 slices of pizza. I apologize. I wanna take out E from this discussion for the time being. So F makes sense because F has more of both of the goods that, well, more of the both, at least one of the more of one of the goods, which is the pizza, than A. So F probably gives the consumer better utility or more utility than A. I changed my mind. I'm gonna keep my I wanna bring my E back as well. So so I'm gonna talk about E. I'm gonna talk about E, and then I'm gonna add E. I'm gonna compare F, and I'm gonna compare B. If you compare these 3 bundles with A, you should see that all of them are better than A, because all of them either offer more of one good or more of both. So it means that if A is, let's say, on I2, B, E, and F has to be at a higher indifference curve, let's say I3. Okay, so that's good. Now let's compare between, let's say, C and B, right? There is no theory that E, B, and F are all on the same indifference curve. We have just they are just drawn at random, but we know that B, E, and F will be on an indifference curve that is higher than I1, where point A is. I hope that makes sense. Now, when you think about compare between B and C, you should see that C is better than B in every aspect. So if B is on indifference curve I3, C will be on a higher indifference curve I4. Okay, now let's look at now D, right? D probably is better than A because D offers more Coke. D probably is I don't know, probably is worse than E, right? Because E offers more of both goods. So if E is on I3, D has to be on a lower indifference curve. Let's call that I2. D therefore will be at an indifference curve higher than I1 and lower than I3. So what we have just done, we have just placed each of these bundles in our two-dimensional space, and we see that higher indifference curve should always give you higher utility because they will always involve a better or more of both goods, or at least one of them. So more goods, more utility, higher indifference curve. They're all the same thing. Okay. The next property of the indifference curve is very, very important. So let's look at what the property is. The property is that indifference curves cannot cross each other. Okay, and let's imagine, in order to prove that indifference curves cannot cross each other, let's assume that they do. Okay, so let's say I1 and I4 crosses each other, and if I1 and I4 crosses each other, then you should see that there is a problem, right? Because if you think about the location of B and C, B is on I1 and C is on I4, B actually has more of both goods than C. So B should be preferred to C. You know, B should give you more utility, right? The problem is that since B and I1 and I4 cross each other, B is indifferent to A, meaning that for the consumer, A and B should give the same level of satisfaction, and A and C are also indifferent, and that is a contradiction, right? So it seems like based on the location of B and C, B should give the consumer better utility than C, but since they cross each other, B should give the consumer same level of utility, and that cannot happen. Two things cannot happen at the same time. So there is a contradiction. So it proves that the indifference curves really cannot cross each other. The last one is that the fourth property is that the indifference curves are bowed inward. What does that mean? It means that as you move down the indifference curve, you are willing to give up less and less. What does it mean? So let's imagine that you are at A. At A, you have a lot of mangoes and you have very few fishes. So you might think that, hey, I don't have that much fish, so I want to get some fish, and the amount of mango that you would be willing to give up to get 1 unit of fish is 6. If that is that's obviously an arbitrary number, right? But it becomes important when you compare A with B. At B, notice that in order to get the same fish, you are now willing to give up less mango, just 2. Why? Because at A, you had a lot of mangoes and you are desperate to get fishes. At B, you now have fewer mangoes and a lot of fish, and you are not interested in getting an additional fish. This very important idea will also be discussed in a minute when we look at the last property, which is the slope of the indifference curve. The slope of the indifference curve has a name. It's called the marginal rate of substitution. The marginal rate of substitution is the rate at which the consumer is willing to trade one good for another good. So as a rule, the rule is that the marginal rate of substitution is let me take that back in a minute. There is a mistake here. I wanna clarify that mistake before I. So when you think about the marginal rate of substitution basically tells you how much of the vertical good that you give up to get the horizontal 1 unit of horizontal good. So you can see that when you are at point A, the amount of X that you are willing to give up is 6. The amount of Y good, this is the mango, you are willing to give up to get 1 unit of fish is 6, so your marginal rate of substitution is the ratio of those two, so it's 6 divided by 1, 6. So that's the margin slope of the, so this is rise over the run, right? So remember what slope is rise over the run. For B, the rise is 2 and the run is 1, so the slope is 2. So the slope is 2. So the marginal rate of substitution is 6 at point A and the marginal rate of substitution is 2 at B. Okay. Notice that the marginal rate of substitution is going down as you are moving down from A to point B. So we should all see that as you move down the indifference curve, the slope of the indifference curve goes down. That's why it has this sort of convex shape. And it also follows the law of diminishing marginal utility. You don't probably see that at this point of time, but we are going to connect these two ideas in a minute. Okay, give me a minute. Okay, so that's our indifference curve. So we have looked at several properties. Let's review them one more time. So the first is that it's downward sloping, and then higher indifference curve indicates higher utility. Indifference curves do not cross each other. They are bowed inward, and the slope of the indifference curve is called the marginal rate of substitution. Let us now move to the next concept. The next concept is called the budget constraint. The budget constraint is an equally important concept in economics. So let's read the budget constraint. In order to understand budget constraint, I probably need to raise the thing a little bit. I first want to focus on a little bit of this one on the left hand side. A consumer budget constraint is the amount of income he or she has available to spend on goods and services. So it's a very simple idea. So notice that Dave has $10, pizza cost about $2, and Coke cost about $1. So based on the income that Dave has, our table shows different combination of goods and services that Dave can purchase, right? So G indicates 0 slices of pizza and spending all money on Coke. That would give you $10. You have K, where you buy 4 slices of pizza that cost you about $8, and then you also buy two cans of Coke that gives you about $2, so you can also buy 10. When you look at these combinations of goods and services, these J, K, H, and all of them give you different combinations of good which you can afford or attain given the income that you have. When you plot these points on a two-dimensional space, we get a downward sloping straight line called a budget constraint. All these points that you just looked at that are on the budget constraint are what we call attainable. You can also buy something less than the combinations that have just been outlined. So any combination that is below the budget constraint are also attainable, and any combination above the budget constraint are unattainable because you simply cannot purchase them. Okay. So that's our budget constraint. It's a straight line. It's a downward sloping straight line. Let us now move back and then talk a little bit about the slope of this budget constraint. The slope of the budget constraint is again the rise over the run. It's a very simple idea again. Let me just make that a little bit visible. Okay, make that a little bit visible. So the slope is like the rise over the run. So imagine that you move from C to D, which is two of the points. So when you move from C to D, you give up the amount of mango that you give up. This is another example, obviously. The amount of mango that you give up is 200. The amount of fish that you gain is about 50. So the slope is 200 divided by 50, and that is like -4, right? Because you give up 200 units and you gain 50 units, so the slope is about -4. So that's the slope of the budget constraint. Notice that for the budget constraint, the slope is constant, right? It's a straight line, so it's not like the indifference curve. So I guess the budget constraint is much easier to understand. Now there are things that changes the shape of this budget constraint, and I think we need to understand that before we look at the optimal stuff. First of all, when there is an increase in income, your budget constraint is going to shift upward, meaning that when your income increases, you can basically afford to buy more of both or more of everything. When your budget constraint, when your income goes down, your budget constraint shifts to the left, just like the one that you're looking at, because you can now afford to buy less of everything. When the price of one of the goods change, our budget constraint pivots. Our budget constraint pivots. In the particular example that you're looking at on the right side, the price of mangoes have gone up, which means that you can still afford the same amount of fish, but the amount of mango that you can afford with it has gone down, which has caused the budget constraint to really pivot inward. So when the price of a good goes up, budget constraint pivots inward. When the price of a good goes down, budget constraint pivots upward. Okay. Let us now look at the application of these two. So we have just spent a substantial amount of our time to develop this concept of indifference curve and the concept of budget constraint. Indifference curve shows us optimal consumption of shows us different combinations of bundle goods that give us the same utility. Budget constraint shows us the different combinations of good that we can afford. You should see clearly that there is a connection between these two. Because if you remember what we talked about utility maximization, it is the maximum utility that you can attain given your income, right? So therefore, in order to maximize utility, you need to find a bundle that gives you the highest possible indifference curve, but still keep you affordable. So you want to find a bundle that is both on an indifference curve and on a budget constraint. Let's look at some of these options. So we have put the indifference curve and the budget constraint in the same two-dimensional space, and there are a bunch of indifference curves. You can see that some indifference curves are like some consumption bundles were like A or D. You can see clearly that none of them are really optimal, right? They are not maximizing your utility because you are operating on a region of the budget constraint where basically you are not doing anything. You are not keeping where you are not utilizing all your income. So this is not where you want to be, right? Notice that at point B you are at a point which is the highest indifference curves compared to I1, I2 and I3. You are still on the budget constraint. So B is a bundle that is both affordable to you and also ensures that you are on the highest possible indifference curve. So the question is, why am I choosing B and not even a better option such as point C? Because C could give me or get me to a higher indifference curve. But why cannot I choose C? The answer is very simple. C is unattainable because C is over the budget constraint. So out of all the options, notice that A and D, which I have somehow completely they are completely hidden under all these writings that I have. Between A and D and B appears to be the best possible combination for the consumer that gives him the highest possible level of utility and also makes it just affordable. We have just shown that C is unattainable, so C is just beyond comparison. Now what about E and F? E and F gives us the same level of utility as B, but E and F are not attainable. They are unattainable because they are over and above the budget constraint. So out of all the options, B is the only consumption bundle that helps you to attain the highest possible utility level and still make it just affordable for you. So B is our optimal consumption bundle. Okay, what we're going to do now is we are going to show that we can use the indifference curve budget constraint approach to show the derivation of a demand curve. And in this case, we are basically thinking about a normal good. The example is very straightforward. You were originally consuming, let's just 1 minute. You were originally consuming at point A, let's call this point A, where you were buying 4 units of the vertical good Coke and 3 units of the horizontal good, which is pizza, and suddenly the price of the pizza have gone down. So if the price of pizza goes down, your budget constraint sort of pivots, and that allows you to have tangency with a higher indifference curve, where you are going to find the optimal consumption bundle at this point B, where at point B you should see that you are buying less Coke and more pizza. I want to avoid the Coke issue. I want to just focus on the pizza. Notice that in case of a pizza, as the price of pizza have gone down, making the budget constraint pivot, you have moved from A to B, and at B you are buying more pizza than before. What does that mean? In the lower panel, if A was the bundle associated with the price before and B is the bundle associated with the new price, which is actually a lower price, you are now buying more at point B of this good. So when the price went down, you are buying more of this normal good, which means that the demand curve for pizza is a downward sloping demand curve. What we have just shown is that our optimal consumption bundle based on indifference curve and budget constraint are very much consistent with the law of demand. Okay, now what I want to do now is I want to spend a little bit of time trying to understand these changes. These changes are not really straightforward, in a sense that you look at these price changes and you see changes in the consumption bundle, but you really do not know how are these changes happening. Because remember, we said that whenever the price of a good changes, 2 things change at the same time. One is this substitution effect and the other one is this income effect. So we want to now spend a little bit of time trying to decompose these 2 ideas. So please stay with me. I want to first focus on the graph on the left side. Okay, and I want to go very slowly, so because this is a fairly complicated concept. So again, we are starting with a situation where our original bundle is at point A. So A is where we are originally consuming. Our original budget constraint was the green line, the inside the green line, and then our budget constraint pivots. And we move to point C. So we basically move from point A to C, but we really need to now decompose that. Now we know that whenever the price of a good goes down, there are 2 things happening at the same time. There is an income effect and there is a substitution effect. In order to understand substitution effect, we need to first keep the purchasing power of the consumer constant and see how he responds to this price change. So the way we do that is that we start with the new pivoted budget constraint, which is the one that you're looking at right now, the new pivoted budget constraint, and we draw a parallel budget constraint downward until the artificial budget constraint is tangent with the original indifference curve, which means that we are basically drawing this new budget constraint by taking away this extra purchasing power of the consumer. So between our artificial budget constraint and the original budget constraint, the purchasing power is the same. The only thing that is different between these two are the price, and you can see that they have different slope. So their budget constraint, as we know that the slope of the budget constraint is the ratio of the prices. With two different prices, we have tangency at point B, where the consumer now moves from A to B by buying more of the good which has now become cheaper. So this is pure substitution effect. The substitution effect tells you that when if you were originally at point A and the price of the horizontal good has gone down, if I keep your purchasing power constant, you should buy more of the cheaper good which you have done. So a movement from A to C is substitution effect. In order to understand the second part, we now give our consumer this extra purchasing power back. So now we are comparing between C and, sorry, this is, I apologize, this is B, right? So this is B. So when so a movement from A to B is basically substitution effect. Then we are now comparing between B and C. So B is on the artificial budget constraint but tangent with our original indifference curve. C is on our new budget constraint and tangent with a higher indifference curve. Notice that between B and C, the only thing that is different is the income, right? The prices are the same. Why? Because the artificial budget constraint and the original budget and the new budget constraint are parallel to each other. So between B and C, your income is different. At point C, your income is higher. At point B, your income is lower, but your prices are the same. Now, when you move from B to C, this is pure income effect, because your income effect tells you, remember, this is a normal good. Your income effect tells you that if your income increases, you buy more of that good. So, let me take a moment to delete all these. This is recorded so you can go back and understand those directions again, and we just want to focus on the idea that a movement from A to B is substitution effect, a movement from B to C is income effect, and that's all there is to understand about how optimal consumption bundle changes whenever the price of a good changes. We can also think about situations where the income of the person changes. In this, so you can look at that on the right graph. So the original bundle was, tangent with indifference curve I1. When in this case income has gone up, budget constraint has shifted up, where you now have optimal consumption bundle between the new budget constraint and a higher indifference curve. Which basically is showing that you are buying more of both goods, and it makes perfect sense. So when income increases, you usually buy more of both. When price changes, that's when things get complicated. Okay, the final thing that I'm going to talk about is this synergy between what we have just looked at and the utility maximization that we talked about before. So in the first part, we looked at marginal utility per dollar being the way to optimize or maximize your utility. In the second part, we looked at marginal utility per dollar. We looked at indifference curve and budget constraint as a way to maximize your utility. How consistent are these two ideas? As it turns out that they are very consistent. They're very consistent. So let's look at that. Okay, so we're going to first look at the discussion in the left side. First of all, let's imagine that Dave is indifferent between these two artificial bundles A and B. Okay, so when Dave moves from A to B, he gives up remember what A and B is. A and B were on the same indifference curve before. Coke was on the horizontal axis, pizza is on the vertical axis. Coke is on the vertical axis, pizza is on the horizontal axis. when you move from A to B, so you're moving down the indifference curve, you are giving up Coke and you are gaining pizza. So how does this make our consumer indifferent between these two? So when you move from A to B, the loss in utility from consuming less Coke has to be compensated by gain in utility by buying more pizza. So you can think about this as follows. When you move from A to B, the change in quantity times of Coke times the marginal utility of Coke, this is the loss in utility by buying less Coke, has to be equal to the increase in utility by buying more pizza. So that will be equal to change in quantity of pizza times the marginal utility of pizza. So when you reorganize that, you get this very important equilibrium condition. So you can see this graphically as well. So when you move from A to B, you give up Coke and you gain Pepsi. So the condition that you're seeing on the left hand side basically shows the loss in consumption, loss in utility from C1 to C2, and the right hand side basically tells you the gain in utility by moving from P1 to P2. When you reorganize this, you see that the change, what you get is an equilibrium condition where it says that the change in quantity of Coke divided by change in quantity of pizza is equal to the ratio of the marginal utility of pizza and Coke. Stop here for a moment. Okay, so when you look at the first term, you notice that this is nothing but the marginal rate of substitution, right? This is the slope of the indifference curve, and the right hand side is marginal utility per dollar, marginal utility of these pizzas. So what is marginal rate of substitution? Marginal rate of substitution is the slope of the indifference curve. Okay, so we are optimizing here, right? At an optimum level, we know that the indifference curve is tangent to the budget line. So the slope of the budget line is basically the price of Pepsi divided by price of pizza divided by price of Coke, right? So that's the slope of the budget constraint. And at the optimal, the marginal rate of substitution is basically equal to these price ratios. Okay, what does that mean? It means that if you now think about marginal rate of substitution in this very important equilibrium condition, so we just got that marginal rate of substitution is equal to the ratio of the marginal utilities, and marginal rate of substitution is also equal to the ratio of the prices according to the optimal consumption bundle, where indifference curve is tangent to the budget line. You eliminate marginal rate of substitution from the middle, you reorganize this equation, and you get our familiar marginal utility per dollar condition. So our optimal consumption bundle based on indifference curve and budget constraint are also consistent with our marginal utility per dollar from the first segment of this lecture today. So that really concludes our discussion. I have one more thing that is in the slide where there is some discussions about how you can use the graphical interpretation, the graphical tools to understand how the demand curve for given good looks like. You can also read that on your own. So I hope this lengthy lecture really clarifies a very complicated sort of idea in your syllabus, which is a discussion about utility maximization and how consumers can find the optimal consumption bundle. So thank you very much. If you have any question, please feel free to get in touch with me. Thank you and have a nice day.